Assalamu alaikum. How are you, students? Hope you stay safe at your home and using your quarantine period effectively. Welcome. Physics class for standard 9-10, chapter 5. Me, Mafraful Shati. Today, I will explain chapter 5. Today's topic, pressure in liquid, Archimedes law and buoyancy. Pressure in liquid. We will find out the pressure at a point inside the liquid. Pressure at a point in a liquid means a force exerted perpendicularly by the liquid on unit area, the point in the liquid. Suppose we consider a point at the bottom surface of the liquid, the container in which the liquid is taken. Suppose at this point we will find out the pressure. So we will consider an area around that point. If pressure is not equal at all points of a particular place, then in order to calculate pressure at a point of the place, it is necessary to consider a very small area around the point. Such a consideration is needed so that we may assume there is no difference of pressure within that very small area. Look, everybody, the bottom surface area of this container is A, and liquid is kept in the container. The height of the liquid is H. So the volume will be, volume equal to length into breadth into height. So here volume can be written as area into height. Here, from the previous lecture, pressure equal to force per unit area, P equal to F by A. So here, what will be the force? Force will be exerted by the liquid that is kept in the container. And force is weight is a kind of force. Weight can be found out by weight equal to mg. So here force also will be mg, and mg force will be acted on a surface area A. Now we will derive the formula of pressure at a point in the liquid. So volume of the liquid over a surface area A is what? AH, that I have shown you. If the density of the liquid is rho, then weight of this liquid or force is what? F equal to mg. F equal to mg. And volume equal to what? Mass per unit, density equal to mass per unit volume. So mass equal to density into volume. From the previous lecture, density equal to m by v. So m equal to what? M equal to v rho. But earlier I have shown you volume equal to AH. So we can write m equal, in place of m we can write v rho, but v is AH. তাহলে কি হলো? AH rho g. Therefore pressure equal to P equal to F by A. Here the applied force is AH rho g divided by A. That means what comes? H rho g. Okay. You can also think that you can find out the formula of pressure by P equal to F by A. Yes, you can find out, you can use this formula P equal to F by A for finding out pressure when the applied force is given and also the surface area is given. Again, you can also use the formula P equal to mg by A, but not at all time, because if you want to find out the pressure at a point inside the sea, then P equal to mg by A, you can't use that formula. Why? Because you can't measure the uh, whole mass of the water of the sea. It is not possible for you. And then uh, you can find out pressure at any point in the liquid. So in a liquid, if you want to find out the pressure at any point, then you have to use this formula, that is AH rho G. Okay, so H, the depth of the sea, you can find out easily, and the density of water, seawater, it also can be find out. G is known, the value of G is known. So we can use this formula rather P equal to mg by A. Here A and A, these two A will be cancel out each other. Then what will remain? H rho G. So pressure of at any point in a liquid equal to H rho G. That means this pressure depends on H, rho and G. But here rho and G is constant, because the liquid which we will take, that's density, rho is constant, and the G, that means acceleration due to gravity, it is also constant. So P is proportional to what? P will be proportional to H. That means the more the depth, the more the pressure. The less the depth, the less the pressure. Look here, I have shown you in another way. Here the depth of the liquid is H, and we have to find out the pressure at this point. So the area is A and height is H of the liquid column. Then the volume equal to AH. So pressure P equal to F by A. F equal to what? mg by A. That I have told earlier. You can't use this formula to find out the pressure at any point under the sea. So you have to use this formula rather that of this formula. So again, you know, density equal to mass per unit volume. So mass equal to density into volume. That means rho Vg divided by A. Again, V equal to, here I have shown you V equal to AH. So rho into AH into G divided by A. A and A, these two A will be cancelled out. So what will remain? Rho GH or AH rho G. You can also tell rho GH or H rho G, these two are same, whatever you like. So pressure in liquid is not affected by area. Look, in this formula, there is no value of area. That means pressure of liquid depends only on the height. It doesn't depend on the amount of area. Earlier I have told you pressure depends on height. So here I have taken a beaker and there are 3 holes. Look, at 3 different height, and as pressure proportional to height, so pressure will be more in which hole? Can you tell me? Yes, pressure, this is the highest depth, right? From the surface of the water to this position, that depth is the highest. Then this, then this. So the pressure will be least at this point. That's why water comes very nearer. Then from this hole, water goes a further distance. But from the lower hole, the pressure will be much. That's the water will move a larger distance with greater velocity. You can also see this in your practical life. If you stay in a 10-story building, then the speed of water will be slow than that of the people who stay in third floor or first floor. because the more the depth, the more the pressure. I think pressure in a liquid is clear to you. Now I will go to Archimedes law. Who was Archimedes? Do you know? A Greek scientist. A Greek scientist named Archimedes measured the upward thrust exerted by the liquid or gas on a body immersed in liquid or gas for the first time. That's why the result of this experiment has come to be known as Archimedes Principle. Look, if a body is immersed in a liquid, the weight of the body is reduced by an amount equal to the displaced liquid. Okay. Have you any experience of swimming? I think all of you uh, has that experience of swimming. When you go to swim in the pond, you seem your body weight is little bit lighter, isn't it? Again, if you immerse your hand in a tub full of water, then also you will feel your hand is lighter. So where this weight goes? So why this is happening? Do you know? This is happening due to the upward force that is exerted by the liquid towards the body. That means when you swim in the pond, you feel that your body weight is less than that of the land. Why? Because when you swim in the pond, that time water also exert a force towards you. That's why you feel yourself lighter than your actual weight. So that I will explain now. So before explaining Archimedes' law, I want to explain buoyancy. What is buoyancy? Any body wholly or partially immersed in a fluid experiences an upthrust equal to but opposite it in sense to the weight of the fluid displaced. When any object is kept in liquid, then an amount of water will be displaced. Look, here I have shown an example. You have to remember one thing, the buoyancy force is equal to the weight of the displaced water. Look, if you take an object and you measure the weight of the object by the spring balance. Here, the unit that is LB, it is known as poundal. It is also one kind of unit of force. So here, the weight, force or weight. Here, the weight of the object is 7 poundal. Okay. Before immersing in the water, and here in the beaker I kept a hole, then so that the extra water, the displaced water can come out, can drain out through this hole, and put it in this pot. Here I kept a tub. Look, when the object is immersed in the liquid, that times you will surprisingly find out that its weight become 4 pounder. That means it loses 3 pounder weight. Okay, and when you immerse the object in the liquid, some water is displaced. So the weight of the displaced water is what? 3 pounder. Okay, that means the weight which is lost by the object when it is immersed in water is equal to the weight of the displaced water. Now, I will show you how to calculate buoyancy. So we have said many times that pressure in a liquid or gas does not work in a definite direction. It works in all directions. When you keep any object inside liquid, then the liquid will exert pressure on the object at all direction. Okay, from each and every direction the liquid will exert force. Look, from the left and from the right direction liquid will exert pressure on the object. Okay, but here the distance, two distance are equal, so that's why the two force will be cancel out. But if we consider this point and that point, the force will not be equal. Why? Because the depth is different. That means the pressure at this point and the pressure at this point will not be equal. Obviously, the pressure, pressure equal to, we got the formula, pressure equal to H rho G. So the pressure must be greater at this depth, that means H2. So look, here I have taken one cylindrical object whose upper surface and bottom surface has an area, that is A. The height of the cylinder is H and the cylinder is immersed in the liquid, and the height from the upper surface of the liquid to the upper surface of the cylindrical object is H1 and the bottom surface is H2. So pressure on this surface will be what? P1 equal to H1 rho G, and the upward pressure acting on the lower surface. This pressure P1 equal to H1 rho G, that is acting on the upper surface of the cylinder, and the upward pressure acting on the lower surface. That means the liquid exert a pressure on this lower surface. Okay, so P2 equal to H2 rho G. Okay, therefore the downward force acting on upper surface and upward force acting on the lower surface are respectively. So from the calculation you are obviously understand that the pressure on the downward surface will be more. That means a bottom surface will be more, as the bottom surface, in this bottom surface the liquid exerts a upward pressure, and on the upper surface the liquid will exert a downward pressure. So the pressure, upward pressure, as the upward pressure is more than that of the downward pressure, so by subtracting those two pressure we can get the resultant pressure. Therefore the downward force acting on upper surface and upward force acting on the lower surface are respectively pressure equal to F by A. So F equal to pressure into area. So F1 equal to, that means I have told you downward force, F1 is the downward force, F1 equal to A into P1. Area is same, upward surface and downward surface area, those two area are same, that is A. So F1 equal to A into P1. That means P1 is the downward pressure at this point, A P1. But P1 equal to, we got what earlier, H1 rho G. That means F1 equal to A H1 rho G. And F2 equal to, again F2, that is the upward force acting on the lower surface. Look, upward force acting on the lower surface, F2 equal to, area is same, that is A, and here pressure is P2. So again I can show you P2 we already got, P2 equal to H2 rho G. So F2 equal to A H2 rho G. As the value of H2 is greater than H1, so we see the value of F2 is greater than F1. Look, H2 is greater than H1. That's why the value, that means the force of F2 will be greater than that of the F1. Therefore, the resultant force will be upward and its value will be F equal to F2 minus F1. You know, if two forces are acted on an object from opposite two direction, and if one force is greater than that of the other force, then by subtracting those two forces we can get the resultant force. Here the resultant force F equal to F2 minus F1, that is equal to, we know F2 equal to A H2 rho g, and F1 equal to A H1 rho g. By putting the value, A is common in both cases because the surface area is same, so A can be taken common, A into H2 minus H1 into rho g. Okay, so H2 minus H1 equal to what? That is the height of the cylinder. Look, from the surface of the water to the bottom surface, height H2. From the surface of the water to the upper surface, height is H1. So this is the height of the cylinder, that is H. So H equal to H2 minus H1. So finally we can get F equal to AH rho g. As AH is the volume of the cylinder, rho is the density of the liquid, and g is the gravitational acceleration. Therefore, the force exerted upward is equal to the weight of the liquid, which has the same volume as the cylinder. This is precisely known as the Archimedes law. The upward force is called buoyancy, and finally we can get F equal to AH rho g, and we can also write it V rho g, because you know AH means V, volume. Area into height is volume. So you can also write it as V rho g, and V rho g is the buoyancy. So if in any math you have to told to find out the buoyancy, then you can use this formula F equal to AH rho g or V rho g. Okay, where V will be the volume of the liquid that is kept in the container, and rho is the density of liquid, and g is the acceleration due to gravity, that is constant. Look, by this figure I think you will be more clear. Here the mass of the object, m is the mass of the object, and rho, this rho is the density of the object, and this rho is the density of the fluid. Here buoyancy means upthrust or upward force that is exerted by the object on the liquid, and the object's weight, that is mg, will be towards the downward direction, because you know acceleration due to gravity, the direction of acceleration due to gravity is always towards the downward direction, and due to this upthrust any object can float in the water. Here I will show you a video which will make you more clear to understand Archimedes law.
Say you have a beaker filled with water and you put your index finger inside it. You'll observe that the water level rises slightly. You put in 2 fingers, the water level rises a bit more. And now when you put in your hand up to the wrist level, you'll see that the water level increases significantly. The ancient Greek mathematician Archimedes observed something similar when he got into a bathtub. When he got in, he realized that the level of water went up. In both the cases, you notice that the water is displaced by the object that goes in. Keep this thought in mind. We'll come back to it soon. In our previous videos, we've seen that when an object is placed in or on the fluid exerts a buoyant force on it which acts upwards. The Archimedes Principle goes just one step further in saying that the buoyant force applied by the fluid is equal to the weight of the displaced fluid. We can take a simple example to understand this. Take a 5 kg solid object and suspend it by a spring balance. The balance will read 5 kilograms. Let this be the first case. For the second case, take a beaker of water which has a small opening at the top. The water in the beaker is filled right up to this point where the opening is. And we keep a small container under the opening. Now slowly lower the solid object into the water and you'll see that the reading will be lower number as compared to the previous case. Why is that? It's because of the buoyant force acting on the object. You'd have also noticed that some water was displaced. Now in this context, we can say that the weight of this displaced water is equal to the magnitude of the buoyant force acting on the object. That's the Archimedes Principle. When an object is immersed fully or partially in a fluid, the upward force applied by the fluid on the object is the same as the weight of the fluid displaced by the object. Where is this principle applied? Can you think of examples? How do you think large steel ships float? It's simple. If the weight of water displaced by the vessel below the keel is equivalent to the vessel's weight, then everything above the keel will remain afloat. That's because the water too applies an upward buoyant force on the ship, which is same as the weight of the water displaced by it. There's just one important concept left in this section, and that's relative density, which we will cover in the next lesson.
So today, to finish my lecture, there is a moral for you. A dream doesn't become reality through magic. It takes sweat, determination, and hard work. Thank you, everybody.